Hello all, in today's session, let me analyze the analysis of asynchronous sequential circuits. As we already learned, so in your sequential circuits, so we have two classification, asynchronous sequential circuits and synchronous sequential circuits. So coming to synchronous sequential circuits, so internal states are changing based on your clock signal. So here the clock will play an important role that can change its output. So based on the triggering of a type of triggering, whether it is a clock trigger or a rate trigger or level trigger. So the state change in a synchronous sequential circuits depends on your width of the clock pulse, or so the time of occurrence of your clock pulse can control your all the flip-flops, all flip-flops output. So since here the common clock can control the operation of your all the flip-flops which are connected to that clock pulse. So since that, so we have that synchronization between all the flip-flops at a time. So on your given single clock, so it can generate your all the flip-flops can generate your outputs. So until unless your clock is 0, so no flip-flop will give your output. So once the clock applied onto your all the flip-flops, then only the output are generated from your each flip-flop in your synchronous sequential circuit. So hence here, so they were controlled by clock pulses. If any changes are their inputs, so before your clock occurs, so then that may not affect your output of your sequential circuit. Whereas in your asynchronous circuit, sequential circuits, so we have few demerits. So those are here it doesn't have your any control signal. Hence here, so it has to wait for your previous flip-flops outputs. So those only then clock your next flip-flop. So this was your demerit in your asynchronous sequential circuit. Now coming to your advantages. So here the accelerate speed of your machine, so here is high somewhat because it is no need to wait for your next clock pulse. So next it can use your input signals so independently of your clock pulses. So that those input logical levels when it changes in your synchronous sequential cycle, they have to wait for your clock signal. If clock signal is applied to the flip-flops or your circuits, then only you can accept your changes in its your inputs of your circuits. So simply in next, and one more advantage of your asynchronous sequential circuit is, so we can have your simplified circuit where your all the inputs of your each circuit in your asynchronous are independent circuits. So with this simplified circuit, we can construct using your asynchronous sequential circuit, and they are used to communicate between your two circuits where each circuit will operate on your different clock pulses. So in such applications, so these asynchronous, so in such applications we are going to use this type of your asynchronous sequential circuits. Now asynchronous sequential circuit block diagram we have mentioned here. So along with your next states, we also mentioned here the combination circuits also derive some outputs. So now, so including with the n number of input variables, we also introduced your m number of output terminals. So which is from combinational circuit. For example, now sometimes so your next state might be outputs, or sometimes so in your based on your applications, so your combinational circuit output is considered as your output of your asynchronous sequential circuit. Now, if any changes at your input may directly affect your internal states of your asynchronous sequential circuit. So now, so in order to stabilize that output, so we have to wait for certain duration till your present state reaches some. As your next states, if you wanted to get your next state, I have to wait for your present state. So that present state must be stabilized first, and then will these to be fed back as your input, and it can accept your changes in your inputs. So here also we have in your combination circuit, we have your interconnected logical gates, which will also give you a delay. So after a certain time delay, when it changes, when you immediately changes your input, so due to this propagation of your present states. So through some delay elements, so you can obtain your stable states at your output of your asynchronous sequential circuit. Since it doesn't have your clock signal, so we have to wait for a certain time delay. So since that next states are acting like an present state, and when they are moving towards to this feedback, so they would take some time interval that is as taken as your memory elements on the, and these time delay elements are used for storing these present states. Now, so these time delay elements will provide your short-term memory for your asynchronous sequential circuits. And now present states are indicated with the small y1 to yk are called as the secondary variables, and capital Y1 to Y2 are the next states, which are called as your excitation variables. So whenever the input variable changes, it takes some certain propagation time interval through that combination circuit to change their present state of y, and then that next state takes some propagation, then it will be propagated through the delay element because of the new states. So now here we can have so stable system, so asynchronous circuits. So when you have a excitation take inputs as well as your secondary inputs. So yi is equal to capital YI for I equal to 1, comma 2, comma. Okay. So next states are behaving like a present state for your future inputs or which are applied on your asynchronous sequential circuits. Now here, so whenever when we obtain your stable state is for a given value of input variables, the system is stable if that uh, circuit can reach here a steady state condition, then only we could state that. So the asynchronous sequential circuit output is at stable state. So we have a few fundamental modes on your operation of your asynchronous sequential circuit. This mode assumes that one of the input signal changes at a time. So these are the foremost fundamental terms that we have to assume that only one input signal is changing at a time, and only when that circuit is stable in condition. So next, so the time between two input changes, so two input signal changes must not be longer than the time it takes to the circuit to reach a stable state. So these fundamental assumptions we have to assume in order to obtain a stable outputs in an asynchronous sequential circuit. First one is only one input signal must be changed on at a time, as well as so you then only that output will be at stable state. So if you wanted to change your two input changes, so it should not be that input changes much should not be longer than that of your time it takes for your circuit to reach the stable state.